All right, this weekend's lesson is on circles and arcs. We're going to go back over circles again, define a circle so that we can go forward working on chapter 12. The review, I'm going to quickly go over this. A circle is a two-dimensional figure. A circle is not a polygon. Every point on a circle is the same distance from the center, and of course the circle there is the one we're going to circle. It's a donut now. Using our vocabulary, underline the correct word to complete each sentence. A minor arc is smaller than a semicircle. A major arc is larger than a semicircle. You use 3 points to name a major arc, and you use 2 points to name a minor arc. So the arc that is in red is arc KL, and the arc that is in blue will be arc LKJ, or LJK, excuse me. It is in order, just like everything else. LJK. All right, naming arcs. What are the minor arcs of circle A? We're going to draw a line from each central angle in column A to its corresponding minor arc in column B. So angle PAQ corresponds to arc PQ. Angle QAR corresponds with arc QR. Angle RAS corresponds with arc RS. Anybody see a pattern here yet? Angle SAP corresponds with arc SP, and angle SAQ corresponds, of course, with arc SQ. So the minor arcs of circle A are PQ, QR, RS, SP, and SQ. All right, so those are the minor arcs of circle A. Continue on. Arc measure. The measure of a minor arc is equal to the measure of its corresponding central angle. The measure of a major arc is the measure of the related minor arc subtracted from 360. And the measure of a semicircle is 180. So your arc measures, if you'd like to go ahead and put them on the theorem sheet with all the other 20-some theorems from chapter 12, you can go ahead and put those 3 facts about arc measure on your theorem sheet. So we're going to look at circle S to the right there, and at the right for exercise 17 and 18. That's repetitive. I repeat myself when I'm distressed. I repeat myself. Okay, that's an old song y'all don't know. All right, so the measure of arc RT equals the measure of angle RST, and the measure of angle RST is 50 degrees, so the measure of arc RT is 50. Define TQR, the big arc. The total measure of a circle is 360, so we're going to subtract RT from that, so we subtract 50 from 360, and it equals 310.
Mr. Ward, please call the front desk.
All right, continuing on. Postulate 10.2. You definitely need to put this on your theorem sheet. Arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. So it's like the segment addition postulate and the angle addition postulate. You just take 2 arcs and you add them together. So major arc ABC equals minor arc AB plus minor arc BC. So it's looking at the circle at the right, AB equals 40 and BC equals 100, so ABC equals 140. If AB equals X and BC equals Y, then major arc ABC equals X plus Y. Continuing on. Finding the measures of arcs. What are the measures of arc PR, RS, PRQ, and PQR in circle C? So the measure of angle PCR is 77 degrees, so the measure of arc PR is 77. The measure of angle RCS is 180 minus 77, so it's going to be PCS minus PCR, so it's 180 minus 77, R 103. So the measure of angle RCS is 103, so arc RS is 103 also. Let's continue on. PRQ equals the measure of PR plus RS plus SQ. PR is 77, RS is 103, and SQ is 28. So all that added together gives me, whoa, 208. That's right. My brain was thinking something else. 208 degrees. So to figure out PQR, I'm going to take 360, which is the whole circle, and subtract away PR, which is 77, and I get 283. So that's how you find the measures of arcs. You look at the angles that they form in the center of the circle, and that calculates what your arc is going to be. Oh, nothing like recording on the afternoon and get all these extra announcements. So here we go, continuing on. Theorem 10.9, circumference of a circle. The circumference of a circle is pi times the diameter. Go ahead and write that down. Explain why you can use either circumference equals pi d or circumference equals 2 pi r to find the circumference of the circle, which is easy. The length of the diameter is twice the length of the radius. Middle school geometry, y'all know that. So let's continue on. Finding a distance. A car has a circular turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. How much farther does a tire on the outside of the turn travel than a tire on the inside? You probably never thought that tires on one side of a car may go farther than tires on the inside. Think about NASCAR. The tires on the right side of the car go farther than the tires on the left side of that car because they always make left turns. The two circles have the same center. To find the radius of the inner circle, do you add or subtract? Think about it for a second. Of course, you subtract. So the radius of the outer circle is 16.1. The radius of the inner circle will be 16.1 minus 4.7, which is 11.4. So first we're going to figure out the circumference of the outer circle. 2 pi r, or 2 pi times 16.1, which equals 32.2 pi. Circumference of the inner circle is going to be 2 pi r, or 2 pi times 11.4, 22.8 pi. So to find the differences, we're going to subtract. You can use a calculator. I can do it in my head. You do it however you need to. 32.2 pi minus 22.8 pi equals 9.4 pi. Now this you need to figure out. 9.4 times 3.14 is 29.53. So a tire on the outer circle travels about 30 feet farther than the tire on the inside. That can add up over time. Theorem 10.10, arc length. The length of the arc of a circle is the product of the ratio, measure of the arc, divided by 360, and the circumference of the circle. So it's important to realize that arc length and arc measure are not the same thing. Okay? So complete the formula below. The length of AB equals the measure of AB divided by 360 times 2 pi r, which equals the measure of AB, it also equals the measure of arc AB divided by 360 times pi times the diameter. So let's look at some couple questions. The length of an arc is a fraction of the circumference of a circle. Oh, forgot my little arc symbol. That is true. The length of an arc is a fraction of the circumference of a circle. That's length of the arc. All right, in circle O, measure AB equals the measure of angle AOB. And that also is true. Arc measure and arc length are not the same thing. All right, so your class must find the length of arc AB. A classmate submits the following solution. Length of AB equals the measure of AB divided by 360 times 2 pi r. 110 divided by 360. So we're looking at AB, and AB would be the 110 divided by 360 times 2 pi 4, and 22 divided by 9 pi meters. So is AC a semicircle? Yes, it is. Does the measure of AB equal 180 minus 70? Yes, it does. Is the length of the radius 4 meters? No. So the error, of course, is the student substituted the diameter instead of the radius for R. All right. I hope everybody understands that you use the measure of the arc to find the arc length. So the measure of the arc and arc length are not the same thing. Again, for the second time. All right. So that's your video for tonight, this weekend. Hope you get all the notes down. When you come in on Monday, we will do work on arc measure, arc length, and circumference of a circle, which you already know should be a piece of cake. And we'll look at circles, and we'll get ready to go on to more segments, chords, and such within circles. Have a good weekend. See you on Monday.